Good afternoon to all my dear students. As we know, last day we studied about the transpose of a matrix. Transpose of the matrix means, uh, and transpose of matrix we know it is obtained by interchanging the row and columns. So today's concept is symmetric matrix. What is the symmetric matrix? A square matrix Aij is said to be symmetric if transpose of A is equal to comes A metric itself, that is Aij is equal to Aji for all I and j. So in simple language I'm just saying that symmetric matrix means that matrix if we are taking the transpose of that matrix, and by transposing we are getting the same matrix as the A, then we can say that that is a symmetric matrix. So let's see the example here: 1 2 3 2 4 5 3 5 6. So when I did the transpose of this matrix, again I'm getting what? 1 2 3 2 4 5 3 5 7. So it is what? It is the A. So in this case we can say it is a symmetric matrix. In symmetric matrix, one thing is notable is there. If we see the principal diagonals, like principal diagonal one elements are in principal diagonals are 1 4 7. So if I will keep the pen here, see, on the principal diagonals, then you can see one thing here: the elements above the principal diagonal like 2 3 5, and in the downside it is also 2 3 5. Then here, from here we conclude that in symmetric matrix we can see that the elements above and below the principal diagonals are same, in the same order and same pattern. Second thing, one more thing is that the symmetric matrix we can find only for the square matrix, like here but with order 3 by 3. So by all these things we conclude that a symmetric matrix is always a square matrix. And necessary and sufficient condition for a matrix to be symmetric is that it is equal to its transpose. That means if we are getting transpose of any matrix, transpose of any matrix is a matrix itself, then we can say that that matrix is a symmetric matrix. And the second point is here: in symmetric matrix, the elements above and below, which I was sharing with you with the principal diagonals, are symmetrically placed. So all the elements above the principal diagonals are symmetrically placed. Then in that way you can also identify that is this matrix asymmetric or not. This will help you, these things will help you in observing the in doing the MCQs. There is no need to do this color one change. You can see directly that if elements above or below the principal diagonals are symmetrical placed, then it is a symmetric matrix. And the next is skew symmetric matrix. A square matrix Aij is said to be a skew symmetric if transpose of A is equal to minus A. That is, Aij is equal to minus Aji for all I and j. It means that what? In skew symmetric matrix, if we are taking the transpose of that matrix, by doing the transpose of that matrix, we are getting negative of the same matrix. Then we are saying the matrix is skew symmetric. So let's see the examples here: 1 2 3 minus 2 0 4 minus 3 minus 4 0. So now by doing the transpose, we are getting here 0 minus 2 minus 3 0 2 0 minus 4 3 4 and 0. So from here we will observe that this is like the same, but here difference of the sign. If there is positive sign, there is negative sign. There is positive, there is negative, and there is negative, there is positive. So there is the elements are the same here like the A matrix, but the sign are different. So or we can write it as minus. If I'm taking minus outside, then we are getting the same matrix as the A. So it means the transpose of this matrix is equal to minus of A. So if we are getting like this, then we can say that A is the skew symmetric matrix. And one more thing, a notable thing is here that the skew symmetric is we can find only for the square matrix. Second thing, all the elements on the principal diagonals, are what? 0. They are 0. And above and below the principal diagonal elements are symmetrical placed but with the opposite signs. Here 2, here is minus 2, here is 3, here is minus 3, and here is 4 and here is minus 4. So on the basis of that we conclude that all the elements in skew symmetric matrix in principal diagonals are 0. So it is clear that all the elements are in principal diagonal are 0, and elements above and below the principal diagonals are symmetrically placed but are of negative of each other. So on the basis of that, this concept, now I think you will be able to do these two questions, question number 7th and question number 8th. So try these questions in your copies. If any doubt, yeah, any you are feeling difficulty, then you can share on my WhatsApp group and I will help you. And my WhatsApp number is 945901319. Thank you and have a nice day.